another example with you in terms of being able to illustrate the bonding between ionic compounds. Okay, we're going to look at illustrating the bonding between beryllium and sulfur. Now, as you progress and we start to look at not just ionic bonding, but covalent bonding, you need to know your periodic table, because if you're given a question where all they tell you is illustrate the bonding between these two elements, you're going to need to know which element is a metal and which element is a non-metal so that you can illustrate the correct type of bonding. Okay, so let's look at how we would illustrate the bonding between beryllium and sulfur. First thing we're going to need to do is we're going to need to figure out the EC for beryllium. Beryllium has an EC of 2. Next, we need to work out the number of subatomic particles in beryllium. Beryllium has 4 protons, 4 electrons, and the number of neutrons is 9 minus 4. So that's 5 neutrons. Remember, the reason we do this is so that we can figure out what the charge on the ion is going to be. Okay, so let's draw our beryllium atom. Put in our nucleus with our 5 neutrons and our 4 protons. On our first shell, we're going to have 2 electrons, and then on our valence shell, we're also going to have 2 electrons. Okay? Now we need to take care of sulfur. Sulfur, if we look at the atomic number, we'll have an EC of 2, 8, 6. And the number of subatomic particles, we're going to have 16 protons, 16 electrons, and the number of neutrons is going to be 32 minus 16, which is also 16. So bear that in mind. Remember, when we're dealing with the atoms always have equal number of protons and electrons. The atoms, when we get to the ions won't have equal number of protons and electrons. Okay, so let's now draw our sulfur. So we put in our nucleus first, 16 protons, 16 neutrons. On our first shell, going to have 2 electrons. And notice I am trying to use different symbols for the electrons on the metal atom compared to the electrons on the non-metal atom. The reason is so that you can easily see where the electron has been gained, what atom the electron has been gained from, what atom the electron has gone to. Okay, so let's look at our beryllium. Our beryllium wants to lose these 2 electrons so that once those 2 electrons have been lost, it will have only 1 shell with 2 electrons in it. The first shell can only hold 2. So it wants to get rid of these 2 electrons. When we look at sulfur, sulfur also wants to gain those 2 electrons, because if it gains those 2 electrons, it will also have a full outer shell. It will have an outer shell with 8 on it. And remember, once it has that 8, it will be full. So what's going to happen? Well, what's going to happen is that beryllium is going to give that electron to sulfur and also give that electron to sulfur. Remember, what we're not going to do is we're not going to draw the electrons on like that. All right, that gets you a big fat X. Okay, the electron cannot be here at the same time as it is over here. You cannot be in two places at the same time, so the electron cannot be here on the beryllium and be here on the sulfur at the same time. What you do is you draw your arrow to show that this is where the electron is, this is where it's going to. This is where the electron is, this is where it's going to. And once you have your atoms, now you need to draw your ions. So, let's start with our beryllium ion. Initially, beryllium had 4 protons and it had 4 electrons. But then it lost 2 of those electrons, so now it only has 2. So there are 2 more positives than negatives. So the charge is going to be +2. Okay? So in drawing your ion, remember, square brackets. There's only one shell, and that shell has 2 electrons. And we go ahead and we put in our nucleus, 4 protons and 5 neutrons. And remember, we put our charge there as well. Charge is +2. Now we come to our sulfur. And for sulfur, we had 16 protons. Initially, we also had 16 electrons, but then we gained 2 more. So 2 plus 16 is 18. So now we have 18 electrons. We have 2 more electrons than protons. So since we have 2 more electrons than protons, it means we have 2 more negative things than positive things. So our charge is going to be -2. So let's draw our sulfur ion now. Alright, so on our valence shell, we have the electrons and the 2 electrons that we got from beryllium. Here they are. So now is the time when you put them on the shell. Put on your second shell. Make sure you always fill up your shells. Your first shell, and put in your nucleus. And then make sure that you put on the charge and the ion. You have 2 more negatives than positives, so the ion is going to be negatively charged overall. Okay? One of the things that we're going to come to as well is that there will not always be one element that is supplying the number of electrons that the other element needs. Sometimes the metal will have more electrons to give than one atom of the nonmetal can accept. And sometimes the metal will not be able to give enough electrons that the nonmetal needs. In other words, what I'm trying to say to you is that there will be times when the elements will not bond one atom to another atom. Sometimes you will have more than one metal bonding with one nonmetal. Sometimes you will have one metal bonding with more than one nonmetal. And sometimes you will have multiple of the metal bonding with multiple of the nonmetal. But at the end of the day, the objective for every single element is that once they bond, their EC ends up being an EC just like a noble gas. So each element's valence shell is full. And once that happens, your bonding has been successful.